What up? It's your boy C Rizzy going over the open-ended review. So this is going over the SGO assessment that you guys took a couple weeks ago. All right, I want to talk about how I scored this and how to do these problems. All right. So each question had the following points. Question 1 was 3 points. Question 2 was a maximum of 2 points, 4 points, 1 point, and the last question was 7 points for a total of 17 points. So the first thing I want you to do is I want you to figure out what was the score you got. Okay, so here's how I graded it. Okay, so here's an example test. So this person got 2.5 on the first problem. I didn't write anything for the second problem, so they got 0 points. Looks like they got a half a point for problem 3. They got 1 point for problem 4, and then they got 5 points for problem 5. So it looks like they got 3, 4, a total of 9 points. So they got 9 out of 17. So what do we do now? Do 9 divided by 17 times 100. This person got a 52.9%. Okay, so I want everybody to do that for yours and figure out what your percentage is going to be. All right, so let's just talk about techniques for test taking. Okay, I saw a lot of questions on the assessment with the following issues. 1, read the directions. Rule 2, read the directions again, because a lot of you were making mistakes just because you weren't reading directions. Rule number 3, if it's a multiple choice question, answer it. If you don't answer it, you get it wrong. If you do answer it, there's a 25% chance you get the question right. So even if you don't know, you take your best educated guess, answer the question, do not leave any answers blank. And rule number 4, if the question is a select all that apply, which a couple of the questions were, only choose the answers that you are confident in. And the reason for that is that when you do a select all that apply, if you get the answer correct, it gets you the most amount of points. But if you choose an incorrect response, it will deduct points. So you don't get to just pick every single answer knowing that you'll get points. So in a multiple choice question, you answer it. If you get it wrong, you get it wrong. If you get it right, you get it right. But in a select all that apply, you get the majority of points if you get the correct responses. But if you pick a wrong response, you lose points. And I'll show you how I worked that. All right, let's do question number 1. The diagram represents a portion of a small city. Maple Street and Pine Street run exactly east to west. Oak Avenue runs exactly north to south. All of the streets remain straight. Then they give you the diagram. Question 1. Which statements must be true based only on the given information above? Okay, read the question again. Which statements must be true based only on the given information? Okay, so I'm looking at a couple words here. Based only on the given information. So you can't assume anything. Only what's given to me. So let's go back up to the top. The diagram represents a portion of a small city. Maple Street and Pine Street run exactly east to west. So what does that tell me? It tells me Maple Street and Pine Street are perfectly horizontal. Oak Avenue runs exactly north to south. So that tells me Oak Avenue is perfectly vertical. So what can we get? Birch Street and Elm Street intersect at right angles. Well, here's Birch Street and Elm Street. They didn't tell me that they were perpendicular. That would be right angles. They didn't tell me whether they run north or south or east or west. So there's nothing that I can assume here. So for this, question A is automatically out. Maple Street and Pine Street are parallel. Well, since they told me Maple Street and Pine Street run exactly east to west, they must be perfectly horizontal, therefore they're parallel. If more of the map is shown, Elm Street and Oak Avenue will not intersect. Well, here's Elm Street, here's Oak Avenue. Since they're not parallel, they'll automatically intersect at some point, whether the map is shown. So this is saying it will not intersect, but we know that it will intersect. So therefore, that's also incorrect. I think I'm going to put the correct answers with a green check. Pine Street intersects both Birch Street and Elm Street. Well, we can see Pine. We can see Birch and Elm. We can see Pine intersects here and there with Birch and Elm, so that's good. Oak Avenue and Maple Street are perpendicular. Well, Oak Avenue runs perfectly north and south, so it's perfectly vertical. Maple Street runs east to west, so it's perfectly horizontal. And we've learned that if a line is perfectly vertical and perfectly horizontal, that must mean they're perpendicular. So yes, that one is good as well. Okay, so this is why this question was 3 points. So this was a total of 3 points. So you got 1 point for each correct response, but you got a half a point off for each incorrect response. So if you answered A or C, you lost half a point. And if you answered B or D or E, you got 1 point for each correct answer. Okay, triangle 2. Question 2. Triangle ABC is defined in the coordinate plane by points A at 1, 1, B at 3, 4, and C at 4, 2 as shown. Shows us the picture. Under which transformations will the image of the triangle be similar to the pre-image? Select all that apply. Now remember with similarity, right? When things are similar, we need a scale factor. Okay? The scale factor is another word for a multiple, right? Now a multiple is a number that we have to multiply to each one. So the question here is that I want to look for transformations where I'm multiplying the x and the y by the same number, by the same scale factor. So I did a couple of examples. So in question A, I'm multiplying, it says negative x and negative y, but if I look at that as an actual graph, here's what happens to A, B, C when I make them negative. It's actually a rotation, and they're similar. In fact, they're not just similar, they're congruent to each other. Congruent and similar mean the same thing, so A works. All right, let's look at part B. In part B, I'm adding 2 to x, but I'm multiplying 2 to y. So does that fall under our rule of it has to have a scale factor or the same multiple to the x and y? The answer is no. Okay? I can't just add 2 to the x and multiply the y by 2. Here's what that picture looks like. Okay? In this one, I added 2 to the x, I multiplied the y by 2, and I got 2 figures, 2 triangles that don't even look the same. Therefore, that can't work. Okay, in part C, it looks like I'm multiplying x by 0.5 and I'm multiplying y by 0.5, which follows our rule of the scale factor with the same multiple, and that's what this looks like. Okay, I took half of all the points, I still get similar triangles. In part D, I add 4 and subtract 2. That doesn't give me similar figures. So therefore, that one's out because it has to be a multiple. And then in E, I'm multiplying the x by 2 and the y by 3. So that's no good also. It has to be the same across the board. So the correct answer was only A and C. Okay, this is why I tell you to read directions. Triangle ABC has side lengths of 3, 6, and 8. Classify each transformation described as producing a triangle similar to ABC or a triangle not similar to ABC. Some of you ignored everything else and just circled one answer. This was not what it said. It said, draw a line from each statement below to its appropriate box. Draw a line from each statement below to its appropriate box. So, some of you decided not to draw lines. You just circled an answer, and that's not going to be right. So, let's draw a line. So, again, to be similar, as we talked about over here, similar means a multiple. Multiply each side length by 3.5. Yep, that's going to be similar. Add 12 to each side length. Well, not a multiple, so that's not going to work. Subtract 2 from each side length. Well, again, not a multiple, so that's not going to work. Divide each side length. Well, if I'm dividing, that's just dividing by 0.75 is the same thing as multiplying by another number, so that works over here. So those are your correct responses for number 3. Number 4, given the 2 triangles shown, find the value of x. Again, this is another similarity problem. So we have to create appropriate proportions. So first things first is that I've got a triangle. I know C is congruent to D. I know A is 68. And the only way this works is if this angle here is 74 degrees, and this angle here is 68 degrees. So if I were to write a similarity statement, triangle, we'll say ABC is similar to triangle. A is congruent to F, B is congruent to E, C is congruent to D. So this helps me because now I can figure out my corresponding sides, right? AB corresponds with FE. BC corresponds with ED. And then AC corresponds with FD. So now this helps me set up my proportion. So my side 6 corresponds with 15. And my side 10 corresponds with my side X. So now we can cross multiply and solve. 6x is equal to 150. Divide by 6. X equals 25. Now this was just a 1-point question, but some of you again left this question blank. If you leave it blank, you cannot get points. You have to answer the question. Okay, on to question 5. So this is a proof. We've done proofs. We know proofs. Do not be afraid to do proofs. The only thing is that we have to look to see what is reasonable here. So choose from the multiple choice options to complete the statement for 2. So part A is the statement. This part is the reason. So let's see. I'm told BA is congruent to BC, right? So we know that BA is congruent to BC. Let's see. Let D be the midpoint of AB. Let D be the midpoint of AC. Let D be the midpoint of BC. Now, remember, sometimes when you are doing statements, you got to look to see what's coming next, right? What's coming next? AD is congruent to CD. AD is congruent to CD. So obviously, if I'm going to create some point D, it needs to be between A and C. So what we're doing is we're creating some point D. So therefore, it has to be the midpoint of AC. So the correct answer for the first one is B. Now the reason. Our reason, every line has exactly one midpoint. Every segment has exactly one midpoint. Every triangle is exactly one midpoint. So now we got to look at what is the difference in the words here. One of these statements has the word line. One has segment. One has triangle. So what did we do the midpoint of? Did we do the midpoint of a line? Did we do the midpoint of a segment? Did we do the midpoint of a triangle? And what did we do? This is AC is a segment, not a line, because a line goes on forever. This is a segment. So that's E. Okay. Moving on to the next part. So the first part was B and E. Okay, question 2. So now again, I'm just going to recreate what we've already done so far. We have our midpoint D. We've got these sides are congruent to one another. Okay, we went through A. This is the midpoint. So what do we got next? So the next one's going to be choose. Angle ADB is congruent to angle CDB. So it looks like what they want us to do is they want us to draw a line here. Right? In part 3, they said AD was congruent to CD, so I'm going to mark that. Now this starts to look like a proof we know how to do. And we know that we've done this before, that BD has to be congruent to BD. And what was that called? That wasn't definition of a perpendicular bisector. Side angle side congruence is trying to prove triangles are congruent. We're not there yet. But this is now reflexive property. Right? That same line that shares the side, that we just called reflexive property. All right, getting closer to the end now. Question 5. So now that we have all this information, right, I'm going to redraw it again. We have BD, right? We proved this was congruent to this. We proved this was congruent to this. We proved this was congruent to this. Do we have enough information to prove these triangles are congruent? And yes, we do. Triangle ABD is not similar. Okay, sorry, part 2, trying to finish this up. So again, triangle ABD similar to triangle CBD, that's not it. Triangle ABD congruent to CBD, angle ABD congruent. So this one's out. It's not angle. We're not doing similarity here, right? We're trying to prove congruency. And why are these congruent? This is side, side, side congruency. And the very last one I didn't necessarily expect everybody to get, because this was part of section 4.5, which I made extra credit for those that did it, 4.4, which was called something called the corresponding parts of congruent triangles, which was called CPCTC. Corresponding parts of congruent triangles are congruent, which just basically said that if I proved to you that this was congruent to this, and this was congruent to this, and this was congruent to this, well, then everything else in these triangles must also be congruent. I can say A is congruent to C now. I can say this angle is congruent to this angle. I can say that angle is congruent to that angle. And that was called CPCTC. So it's something that we didn't necessarily do in class, but it's important to know for the NJSLA. All right, now that's all for me.